All right, so good morning. I'm Tennille Presley. I'm an associate professor of physics. And over the course of the last year, we've been looking at using data science methods to elucidate music's biophysical influence on the body. And the undergraduate student that I have working with me is Mr. Timothy Pittman. So one of the things with music is that in general, it's what I call this very universal language. So irrespective of where you are, they tend to listen to music. And ultimately, we listen to music for a variety of reasons, and one of those reasons tend to elicit some type of emotional response. However, there are some knowledge gaps as it relates to music, and one of the things is really in regards to how music interacts with the body's mechanisms. And so as a physicist, as a biophysicist, what I mean by that is really looking at the electrical response of the body in regards to if you're listening to some music, what happens from, for example, blood pressure, what happens in regards to heart rate, and what happens in regards to something that we call skin conductivity. Another deficit that is out there is a lot of music studies, when you look at them, they lack diversity. They lack diversity in the capacity of genres. So when we think about genres, very commonly, if you pull this information up, you look at it, and the top two genres that are very commonly looked at are classical music and jazz music. People tend to be drawn to these aspects because they tend to make people feel good. They tend to relax you. So ultimately, what happens with these other genres versus just putting this title on just music, and it really hones into those particular genres. And so because of these deficits, there are a lack of data sets really addressing that overlap in regards to the emotional response, in regards to the biophysical response, and really looking at one of the focuses for today with this symposium is diversity, equity, and inclusion. And so there's a lot of deficit in regards to looking at these impacts, these influences in regards to race and ethnicity, as well as various genres, and then especially with respect to age. So what we've tried to do is with this project is to aim to develop a predictive model for identifying whether like individuals will exhibit comparative biophysical outcomes related and based upon similar musical genres. When we talk about like individuals, it can be very broad. So we're starting small, and our idea is to expand out. So like individuals could be, for example, if you have two African-American individuals, will they elicit the same exact type of emotional and biophysical response, and how that overlap may occur? Or if you have two females, will those two females, let's say they are of two different ethnicities, will they exhibit and demonstrate similar responses? So to do this, we started out utilizing skin conductivity. Skin conductivity is ultimately looking at the electrodermal response. So basically, if you have a particular stimuli, our stimuli for this project is music. Taking in that music, ultimately the skin has this unique capacity to account for the electrical response and the electrical activity within the body. By picking up this music, so the individuals that we've recruited, they, in this particular portion, were between the ages of 10 to 55 years old. All of these individuals were African American. So taking that music, when the ear picks up sound, it ultimately travels into the middle ear. It elicits these vibrations. The vibrations go to the brain to let the brain know that it's detecting a particular sound. So what we did with these individuals, we had them to listen to a variety of genres of music: rock, gospel, Afro beats, neo soul. They were also allowed to select their favorite song, and then they also listened in the presence of silence. And they were able to do this over the course of 2 minutes for each integral, and then they had what we would consider as a washout period in between. So we accounted for this, and we wanted to correlate this with respect to Ohm's law. So Ohm's law simply accounts for voltage is equal to your current and your resistance, so the product of the two. And ultimately, you can think of the body as one big electrical circuit. And so the whole idea is connecting this, your skin conductivity and the resistance, they have this inversely proportional relationship with each other. And then taking it back to, does it correlate and coincide with a particular excitement or some type of arousal or emotional response? So we've had a number of outcomes. We've taken this and looked at this with respect to the valence arousal model. And ultimately, one of the first things that we were able to see, the GSR, which is another name for skin conductivity, is just galvanic skin response. In a lot of the literature, again, with respect to this diversity and this generalization that happens, one thing that has been reported is that males tend to have a higher skin conductivity with respect to females. Now, from a biophysical, physiological account, a lot of information isn't out here in regards to why that statement is true. But what we've seen with our data is that it is age dependent and it's gender dependent. So we've seen that older males, and when we say older males, with this population of individuals we've looked at thus far, individuals greater than 35. So the younger is less than 35. The older males demonstrated a higher skin conductivity in comparison to females. Then we saw an opposite effect with the younger population. What we've also seen is that there is a positive valence. And positive valence, ultimately what that means is just more or less of a positive emotion versus a negative emotion. So if you can look at just the demonstration on the right side, high arousal simply means some type of excitement versus low arousal simply indicates or suggests some type of sadness or you're feeling down. So we saw with our younger females, again, less than 35, and with this particular group, the younger female population, this was young ladies who were between the ages of 15 to 19 years old. They actually demonstrated a positive valence. However, their arousal response was variable. So in some instances, we saw before them listening to music versus after, again, they listened to the entire playlist, we saw that some of them actually demonstrated a higher arousal. However, we also saw that some of them demonstrated a lower arousal. And then the other individuals within this pool, they more or less didn't have more or less of a response. So they sat kind of right in the center. So really looking at how this arousal and valence more or less overlaps. And then with respect to genre, we saw that rock exhibited the highest arousal amongst all of the participants. So with this, we have some unanswered questions. We've identified, some information, but really accounting for, okay, what are we going to do next? So one of our ideas, because there is a lack in the data, we want to enhance and expand our data set. So really go into the aspect of accounting for trying to recruit more individuals, look at more individuals in other races, ethnicities, look at more individuals outside of that age range that we looked at. We also want to push towards publication development and submission, also aim towards grant development and submission. And then again, our main idea is to really develop and account for this predictive model. But again, our limitation is really enhancing that number. So with respect to this, we have enhanced some of the numbers. We plan to enhance some more. I know Dr. Aragon is on the top of my list in regards to an individual that I want to pull in. So again, we are aiming to recruit and get more and more data so that we can account for this. And anyone that's interested, it is a completely non-invasive process. All it takes is just placing 2 electrodes on your finger and we're able to measure it with ease. And if you like music, come and vibe with us. I'm sure you will enjoy our playlist. And with that, I would like to acknowledge Dr. William Nick, who is the CADS postdoc. He's been helpful with this project and then the funding with the UNC Research Opportunities Initiative, and then an NSF tip that I have. Thank you.